Moving on, I would like to invite now on the stage Mr. Giorgio La Valle, Marine Engineering Services, M.E.S, Chairman, to give us a speech about the correlation between ship design and LPG storage and handling system. Okay, the floor is all yours.
Okay, good morning to everybody. For me, it is very hard to speak now after Wärtsilä and LG that are very huge companies. Please be patient. I will try to do my best. Okay, a quick introduction of my company. We are a ship designer. I established this company in 1986. Before I was a naval architect in Fincantieri Ship Design office. I started working in 1974, and I designed my first LPG car in 1979, so you can understand how old I am. Okay, my company is a very small one. We are about 30 persons in Trieste. Out of them, we are nine naval architects, one mechanical engineer, and then senior designer and a junior designer. Our activity is mostly extended basic design, what we call extended basic design, that is all the drawings necessary for the classification and construction of the vessel, excluding workshop drawings. Also, we have a survey activity. In the past, we had up to 18 people working in Korea, Japan, Turkey, China, etc. And also, we do special calculation like FEM, thermal analysis. Then we are also providing, since a few years ago, loading computer according to the new regulation, Parimu, etc. Mainly for gas carrier and also for chemical product tanker, etc. How is working here? Press that page down. This is the head office in Trieste. This is our team. Okay, key points. We are very much focused on high performances, and we work very hard on the lines. We will see then how we do. The quality, and we can base our work on continuous feedback from either shipyards, our site team, and also from ship owner, our clients. Okay, we have. There are about 100 ships sailing with that we have designed. Out of them, 60 are gas carriers. Okay. We are also subcontractor of Wärtsilä for some projects in LNG at the moment. This is are some example of our design. Ship from 3,000 up to 40,000 cubic meter. Okay, this is a series of 9,000 cubic meter ethylene carriers we built, two in two in Italy, one in Poland, and one in Turkey, with cylindrical tanks. The last one is a very interesting project with the twin screw, twin skeg solution. And we obtain a really very, very good performance with this vessel, just slightly less than a single propeller. That is really very good results. taking into consideration that we have the redundancy here and also a flexibility, not with this ship but with a chemical carrier, because of the very poor time charter, very poor market, the ship owner decided to run just with one propeller. Some days with one, and some days with the other one. This is a series of ethylene carrier 4,500 we built in Vietnam with a very high speed, 15.8 knots. That was a ship owner request. These are some details of the same ship. Then also a series of 8 3,300 ships built in Turkey, also very performant example of that layout. Also in the last years we are active in LNG small-scale carriers and also LNG propulsion. We are cooperating with major players, of course, not doing anything ourselves, just as subcontractors. Example of thermal FEM, thermal calculation to determine the temperature around the hull and therefore the steel grades necessary. Also, this is also an interesting project that we have these days. Is 7,500. That is a very popular size of LNG at the moment. And this is the biggest project we have done, 40,000. Okay, this is also a very interesting job. Is a conversion. We start from a 3,000 LPG vessel, convert into 3,700 LNG. The work is expected to start end of this year. Okay, other example of spatial calculations. Okay, now the subject of this conference for me is that I would like to analyze the concept of LPG carriers from the point of view of a small independent designer. Of course, the topics of this vessel is the cargo containment system and cargo handling system. Anyway, also the marine part maintain his big importance. When we have to design a ship, we have to approach different players. Ship owner, shipyard, cargo containment and handling system supplier. We have to mediate in order to obtain the best optimization of the full ship. The concept is not that we not need to have the best of the best containment system, for example, and not the best ship. We have to find a compromise between the ship and the containment system. Then there is the ship owner approach. Most of the ship owners in this market have a long tradition, and therefore they have a consolidated experience. They know exactly what they want and what they need, sometimes also in very detailed way. The shipowner staff normally issue outline specification where they specify in detail if they have, for example, limitation in the ship dimension, the speed, the cargo tank capacity, the characteristic and the performances of the cargo system, the volume of the cargo tanks, and so on. The shipyard approach instead is when they appoint an external independent designer, as we are, and this is the case in China, in Turkey, in Italy, we have to provide detailed specification with all the details of the ship, and of course we have to assure the full adherence to the contractual terms, but we have to optimize the weight, steel weight, and the best reduction of the cost of the construction and of the equipment. So this is our challenge. The first days of the design is the most important days. Is a win-win or lose-lose time. We have to use our experience, our database, and to find the optimum compromise among all the factors that I mentioned before. What is very important is to find the best ship lines, hull lines, and the geometry of the cargo tanks. I understand I have to speed up, so just to make an example, we have several chances to have cylindrical tanks with elliptical heads, with tapered heads. We have the possibility to use twin-lobe tanks. Mainly when we have limitation in the ship length, we have to use this kind of tanks below, either with elliptical or spherical tanks, depending on the situation. Okay, I just accelerate. This is what we have not to do. To have wrong lines with, you can see here, it's not our design, of course, with a very bad flow paint that gives problems on the propeller efficiency, on the vibrations, etc. But to find the way to have the best possible flow pattern. And when we do that, as you can see, these are a practical example of gas carriers. We can have a very, very good wave pattern. This is not a joke. You can see this is a high speed for small ships of 100, 110 meters, and the wave pattern is practically perfect. To avoid what sometimes is necessary, if the ship design is wrong, that is the performance nowadays, bad performance is not acceptable anymore, so we have done also this, to cut, not our ship, of course I cancel the name because I don't want to offend anybody, but we have to do also this one. It's okay? Thank you very much.
Thank you very much for this nice presentation. Do we have any questions from the floor also? Okay, then I'll take the cards and ask one question myself. You mentioned about your experience on Type C tanks, the cylindrical types. You also mentioned about the bi-lobe tanks. There has been some initiatives about the tri-lobe tanks. Do you have a view to offer on this one?
Well, this is a very old story. I remember in the 80s, that somebody also designed and studied multi-lobe, not only three-lobe, but multi-lobe. I mean, in the horizontal way and also in the vertical way. Of course it is possible, the technology is there. If in particular project is necessary, it's possible to do.
You have the capacity to...
Yes.
Okay. Thank you very much.
Thank you.